They've given us a point and a line. Y is equal to x means that the intercept is at 0. We can say plus 0, minus 0, it doesn't matter, but the y-intercept is right there. Y is equal to x has a slope of 1. Using our slope-intercept form, y is equal to mx plus b, we know that the slope is 1. So our line will look like something like that. So we have where 1, 1, and so on and so forth. So the first step is to find the slope of the first line, which in this case is 1. The second step of solving these problems in lesson 42 is to find the second slope. The slope of the second line, which can be drawn from the point 7,3. The point 7,3 would be where we have the x as 7 and the y as 3. We have something about here. And there's one perpendicular line that can be drawn from here to that line. And so we're looking for that point, and then we're going to calculate the distance from that point to point P. So the second step is to find the slope of this line here, this second line. If the second line is perpendicular to the first line, that means that it has the negative reciprocal of the slope of the first line. So if the slope of the first line is 1, the negative reciprocal would be minus 1. Because that's simply negative 1 over 1, which is negative 1. The third step we deal with now is we try to find the equation of the second line. We know what the slope is, and we can use the point slope form to find the equation of the second line. All we do is we go y minus y1 is equal to m into x minus x1. And so now we're going to move over here and plug in our values. We have y minus 3 is equal to our slope, which is minus 1, into x minus 7. And so we have the point slope form right here. We go ahead and change it to the point or the slope intercept form. So y minus 3 is equal to minus x plus 7, and then y, we add 3 to both sides, is equal to minus x plus 10. At this point, we have the second equation. The first equation was simply y is equal to x. And so we're going to substitute, or we're going to make them equal, whichever way you want to look at it at this point. This y is equal to x, and here y is equal to that. So x is equal to minus x plus 10. And so all we do is we add x to both sides, and we get 2x is equal to 10. So x is equal to 5. If x is equal to 5, then y is also equal to 5. So the point of intersection would be 5, 5. Now we find the distance from 7, 3 to 5, 5. The distance formula is simply the square root of x2 minus x1 squared plus y2 minus y1 squared. And so we plug in our values. This is going to be our x2, y2, and our x1, y1. And we have 7 minus 5 squared plus 3 minus 5 squared. We have d is equal to the square root of 2 squared plus minus 2 squared. And so d is equal to square root of 4 plus 4. And then all we have left is d is equal to the square root of 8. We should be somewhere around 2.8 and so on. And that's all for this problem. That's the shortest distance from that point to that line. I hope this is helpful as you solve lesson 42 problems.